Hello everyone. Today I am going to give a CAA-2 assignment video presentation for the subject Automata Theory and Compiler Design, whose subject code is 23CSC503. The topic name is Translation of Simple Statements and Control Flow Statements. My name is G.Lalith Vignesh and my roll number is 234G1A0577. And I am going to explain translation of simple statements and control flow statements. Translation of simple statements and control flow statements in compiler design. Introduction to translation in compiler design. The translation phase converts high-level language statements into intermediate code or machine code. It is essential for enabling the execution of programs on a hardware or virtual machines. This presentation focuses on translating simple statements and control flow statements in compilers. What this means is translation phase is a process or a protocol that converts high-level language statements into low-level language, like taking some kind of a code or a program and turning it into machine code or a code that will computer understand, a low-level code. This is called translation phase, and we are going to translate simple statements and control flow statements. Simple statements in programming language. What are simple statements? Simple statements include assignments, input-output operations, and function calls. They typically involve straightforward expressions that do not alter the program's control flow. Translating simple statements involves generating appropriate, intermediate, or mission code for each statement. What this essentially means is simple statements are assignments and operations and function calls that do not interfere with the control flow statements. They stay aside and do not influence the code too much. What they essentially do is simple statements include assignments, input-output operations, and function calls. And this transforms simple statements to generate appropriate intermediate or machine code for each statement. Translating assignment statements. Assignment statements assigns values to variable and are fundamental in programming. The translation involves generating code that evaluates the right-hand expression and stores it in the variable. For example, x is equals to y plus 2 translate into code that evaluates y plus 2 and stores the result in x. What this essentially means is assignment statement is a statement that is used to assign a certain value to a certain variable, and that value is stored in that certain variable. For example, if x is equals to 2, the 2 is a value that is assigned to x, which means the value of 2 is stored in x. Just like that, if x is equals to y plus 2, y plus 2 is a value that is stored in x, even though both are variables. Handling input-output statements. Input statements read data from the user or external devices, while output statements display data. Translators convert these into system calls or library functions in the target code. For example, CIN is greater than X in C++ may translate to a system calling for reading input. What this essentially means is input statements read data from the user, while the output statements display the data that is stored within the devices to the user through the help of monitor or any other output devices such as speakers or any other devices. Control flow statements overview. Control flow statements direct the execution path of the program. Common control flow statements include if, while, for, and switch. The translation involves creating labels, gems, and conditional branches in intermediate code. Control flow statements are simply put statements that control the flow of the program. These use if, while, for, switch, which control the flow of it, which create loops, which destroy loops, which circumnavigate the loops. These are all done within the garb of control flow statements. The translation involves creating labels, gems, and conditional branches that put some conditions like a bridge to the river and for controlling the flow. And just like that, we use these statements to control the flow of the program. That's why they are called control flow statements. And simple statements most of the times do not interfere with these control statements or alter them in any particular manner, and they stay pretty independent from each other. Translating the if statement. The if statement evaluates a condition, executes a block if the condition is true. Translation involves generating code for the condition check and conditional jump instructions. For example, if x is greater than 0, then y is equals to 1. Translate into a code that takes x is greater than 0 and jumps to assign y if true. What this essentially means is every if statement is used when you check a particular statement, and if the statement is true, then you put another statement into action. If the statement is not true, then you won't put it or put it. So you can create a condition, you can create a control, and you can use that condition to control the flow of the program. And just like that, we are going to use if x is greater than 0. If x is really greater than 0, then y is equals to 1. If it is not, then y may is not equals to 1. So we don't put an action to it. And this is what is translated into simple language by showing that x is greater than 0 and jumps to assign y if not true. Translating loop statements. The while loop repeats a block as long as its conditions remain true. Translation generates a label at the start code for the condition and a jump back to the start of the label. For example, y x is smaller than 2, x is equals to x plus 1 involves looping with conditional jumps. While statement is used for looping. While, for example, if while x is less than 2 and x was originally 0 and its value is going to increasing and then this loop happens until the x is becomes 10. It works until x is 9, so it works 10 times and the 11th time it fails because it's no longer in a loop. Handling for loops in Ravel. The for loop combines initialization, condition checking, and iteration statements. Translators generate code for initialization, a label for the test, code for body, and an increment step. The structure enables efficient looping with appropriate jumps and condition checks. Translating switch statements. The switch statements select among multiple cases based on expression. Translation involves creating jump tables or chained conditional branches for each case. Efficient translation minimizes the number of comparisons using jump tables when possible. So what this essentially means is we use jump tables whenever possible to translate the switch statements into a simpler language. We use the translation phase to convert the high-level switch statements that are used in C++ or another code, and we turn it into machine-level code, binary code, and make it much simpler. And in conclusion, translating simple and control flow statements is vital for executing high-level programs. Proper handling of the control flow constructs ensure correct program semantics and efficiency. Understanding these translation techniques is fundamental for compiler design and estimation. This is my presentation on the automata theory and compiler design, translation of simple and control flow statements in automata theory and compiler design. I'm G.Lalith Vignesh. My roll number is 234G1A0577. Thank you for watching this video.